Okay, we're going to make a double pendulum today. Go ahead and open up a regular old English standard inch part for this one. And we're going to start by just making the base for the pendulum. So go ahead and click on that horizontal plane, orient it right side up. Start by just drawing a random rectangle, and I'm going to make this 8 by 5 inches. And try out some of the constraints over here. I'm going to use a construction line that's 2 inches long. And once you have that done, go ahead and lock it in place. So this way the construction line will stay put, and we're going to be moving our rectangle. Use one of these little coincident constraints, and I'm going to grab the center point of my rectangle. You see that little green button? And just center that rectangle on my construction line. Okay, finish sketch, and we're going to extrude this guy up just 1/2 inch. So this is just the base for our pendulum. Next, I'll use the sweep command to create the frame for supporting our pendulum. I'm going to go ahead and make all of these coordinate planes visible. Just right click and say visible, start a sketch on the base plane again. And this is going to be the cross section for the sweep command, just a 1/2 inch diameter circle. If you flip it over, you can see that circle on the bottom of it. Now I'm going to create a sketch defining the path we're going to use to sweep that circle along. Slice graphics allows you to see into the inside of something if you're working on a plane that bisects a solid. I'm going up 10 inches. Again, this is the path that we're going to use to extrude our circle on. Now over 5 inches. You don't have to use my dimensions, but anyways, down 1 inch. So here it is, looks kind of like a hangman's noose. So we have a profile and a path. The next thing we're going to do is come up here to the sweep command and just have a look at the directions they give you for how to use this thing. So we have 2 things to define. We have the profile, which is the circle, and also the path, which is that line that we're going to sweep it along. So make sure you have both of those things selected and extruding as a solid, and then go ahead and say OK. And there you go. There's our support structure for the double pendulum. Okay, now we need some way to attach our pendulum onto this frame. So I'm going to go ahead and slice a little connector into here. Remember, view, slice graphics. Make sure you're cutting into the right side of this thing. And I'm going to go ahead and grab the rectangle that you can make with the center point on it. So that'll allow us to just snap it to the center here really easily. Doesn't really matter how long it is. I'm going to make it 0.2 inches thick, and this is where our pendulum bar is going to kind of fit up inside of there. Extrude. Remember, there's a couple options to extrude. I'm going to extrude up as a whole, so we're subtracting this little chunk out of there. Hit OK, and it's going up 0.5 inches. I'm now going to drill a hole through here. So again, just starting up another sketch, view, slice graphics. I'm going to go ahead and, let's see, I'll turn on my construction lines, then project geometry just to get the outline of my part. And I'm going to use that projected geometry to just draw a rectangle on here to see where that extrusion was before. And I really want to get this nice and centered. So I'm going to connect corners to find the center point for this, turn construction off, and then draw a circle. Let's see, let's do 1/4 inch, 0.25 inch diameter circle, finish sketch. And then I'm going to reach inside of there and extrude it. And this is the nice thing, I can pop it out both sides and just make it long enough that it goes through each side of that. So now we have a good little spot where we can put a link up in there for our first little part of the double pendulum. And before I exit out of this part, I'll go ahead and turn the visibility of those planes off. Remember the dimensions of how you made the top of this thing, because you're going to need to, our next part is going to have to fit up into this little section here. Next up, we're going to start a new part. Inventor, every little solid piece is its own file. Make sure to save everything in maybe just one folder, and be careful about how you name things. For this part, I'm going to start out with just a 1/2 inch cylinder. So this is kind of going to match the frame that we just made. And our frame was 10 inches tall. I'm going to make this guy, let's see, how about 3 inches tall? That should be good. And then 2 of those should hang nicely in our frame that we made. Now, do you remember what the connection in our frame was? I'm going to make this match what was on our frame. So I'm going to use a center point rectangle again. I'm going to make this one out of a construction line and centered. Okay, so this is what was on our top. It was 0.2 inches wide, but I kind of want to make the opposite of this. So I'm going to take and just create 2 rectangles along the side, and that will leave kind of that little tongue in the center that'll hang down in here. So I'm going to extrude this down. Now, we had cut out 1/2 inch. I think I'm going to make this just a little bit longer than 1/2 inch. We don't want it bumping into one another, and you can always go back after we assemble these and modify it a little bit as you see how parts start fitting together here. Okay, so that little tongue is going to fit right up into the frame that we previously made. I'm also going to drill that 1/4 inch hole through the middle of it too. So again, I'm going to turn on my construction line, and this is just to center that hole. So I'm making a 1/2 inch long. Now, it's not going to be exactly a 1/2 inch long diameter, because we're not going through the center of this thing. We're just a little bit off center as the working plane we're on, but we can at least center it on that little cutout. Okay, so here is our 1/4 inch hole that we can drill through it, and this should fit into there. Now, really, you don't want to make the dimensions exactly the same. There needs to be a little bit of tolerance in here, and again, that's something we can come back in the future and bump it out just a little bit bigger or smaller to make it fit well. I'm also going to round off the edges just so it has room to rotate in here. So I'm going to chop off these top 2 corners and chop out that middle. Okay, use the trim command, and you can just scribble around to trim this off. And what I want is just a closed loop where I can trim the corners off of the top and the hole out of the middle of it. That's a little bit of a tight curve, so I'm going to go ahead and we'll need to right click on this and close our loop. So just walk around and make sure it can see some of those corners on this guy. Okay, we'll see if that'll work or not. And we'll go ahead and extrude this guy, both of them as a whole. Okay, so now that we have the top done, we're going to make a couple different links. So the bottom of this I'm going to make just like we made the frame. Now make sure that your rectangle is aligned on here correctly so that you're not 90 degrees to what we're supposed to be here. So you might want to just rotate it around a little bit and make sure everything is oriented the right direction. So again, we're going with that 0.2 inch thickness again. And we're going to carve it out just like we did the base of the frame that we made before. And just like we did the base of the frame before, we'll also need to start a new sketch and drill a hole through it. View, Slice Graphics, and we'll need to get in there and center our next hole. Okay, so here we are just drawing another rectangle using construction lines on the base of this guy. And you might want to have just some scratch paper in front of you and always be sort of recording dimensions so you can remember how one piece fits into the next piece. Okay, so remember the diameter of the circle, it was 1/4 inch, right? So we're just going to make the same holes through everything. Punch that through both sides. Make sure you select that this is going to be a hole, not a solid. Okay, so now we have a little link. We could actually line these guys up to have lots and lots of different pieces of it. So instead of a double pendulum, we could make a triple one or quadruple one. I'm also going to go ahead and add a working plane in here so that we can start sketching in some internal features. So that is just midpoint between two planes. Try out those new working planes. And I'll go ahead, view, slice graphics, and let's just make this guy a little bit lighter. So I'm going to carve a rectangle out of the center of it. I'll use a construction line to bisect this, and this will just give me a center point, and then I'll use my 2-point rectangle here. Turn off the construction line, find that center, and for your links, have some fun with it. Make your own design. So for all of this, don't just copy what I'm doing. Get creative with this thing. See if you can make something a little bit more artistic. So I'm going to go ahead and just punch this thing through with a hole in it to lighten it up a bit. Okay, so once again, don't copy what I'm doing. Try out your own designs and play around with it. This is how you become familiar with all of the tools in here. So explore all the drawing tools, all the modify tools, the different extrudes and fillet commands, and just go through everything in that ribbon until you're familiar with it. Okay, the next thing we're going to do, let's save this as link number 1, and then we can save it again under a new file name as link number 2. And for link number 2, I'm just going to change the end of this thing. Okay, so I'm going to pull up that working plane that goes right down the center of it and start a sketch on there. And what I'm going to do is just make a wrecking ball at the end of this thing. Okay, so there's that working plane. I'll go up here and say view, slice graphics, and let's put a construction center line down the middle of this guy. We can also kind of project our geometry and do that way too if we want. And what I'm going to do is create a circle, and with the circle I'll use the revolve command. So instead of the regular extrude, I'm going to revolve it, and that'll give me a ball instead of a cylinder. So I'm going to just pull this up. I'm eyeballing it. It doesn't really matter how large this thing is. And I'm going to slice it in half, and this is the line I will revolve it around eventually. Okay, so finish sketch. And I'm grabbing that area for the revolve command, define the axis, and 360 degrees all the way around. So we just put a ball on the end of it. And now we have 2 links, one with a ball and one without, and those should all fit together into that original frame that we made. Okay, the next little bit and the new part for this week is creating not parts, but we're going to open up an assembly now that we have parts to actually assemble together. So remember, there's assemblies and parts and presentations and drawing. So this is kind of going to be a new file type here. So we're opening up an assembly, and now we are going to place our parts into it. I will start by placing the base of this, if I can remember where I saved it under. Let's see. It's good practice to choose a file and put all the parts for a single assembly into the same folder just to keep things organized. Okay, so here is the first part. And I could keep clicking and put like multiple objects. So like if you have a bunch of screws that you need to do or a bunch of bolts or something, you just make one of them and then you keep placing as many as you want. Now, before I place anything else, right now this guy is just floating around in the air. And as this is going to be the base of it, I want to constrain him in place. And it's good practice to start out over here on the left-hand side with the origin of your drawing. Okay, so I'm going to go ahead and just turn the visibility onto these planes. I'm right-clicking and then just clicking on visibility. And I am going to constrain this guy's motion to these planes and see if I can kind of nail him down. I'm going to start right up here with constrain. And I'm going to just use, there's a couple different constraints. You can constrain surfaces, angles, tangent to surfaces. You can insert bolts into holes, make things symmetric. So I'm going to start with just the mating constraint. And all you do is I'm going to come up here. I'm going to click on the base of my little base right here, and then I'm going to constrain him, and I can either click on it in here or just come over here and click on it. So my XZ plane here. Apply. Okay, after I've added that constraint, you'll notice under base, I now have this constraint under base. And if I ever want to delete it or edit it, or sometimes you just want to temporarily suppress it, that's all of that stuff is right under here. And you can also right click on it and you can see find the other half, and it will show you what is stuck to what. Now, after this is constrained, if I click on this guy and move it around, it looks like it's not stuck to anything, right? But it only looks that way because of the angle that we're viewing it from. If I turn it on the side and then move it around, now you can see that constraint, right? So you can see that we're sliding along the floor and we're no longer floating around in midair anymore. So keep that in mind, that sometimes you won't be able to see what is linked to what until you get kind of that right angle to look at it with. Okay, so the next little constraint, let me just bring this over here to the front view. So there's the front and right view of this thing. And I think what I'd like to do is to bring him just into this upper right quadrant here. So what I'm going to do is I'm going to constrain the same thing, just the mating constraint, and I'm going to constrain this surface here. See this side surface? And I'm going to link him up with this wall. Here's another thing to notice. I can put him on either side of the wall. So if he ends up being linked on the wrong side, try these two buttons over here. Okay, so then I'm going to say apply. And now if I look straight down at the top of him, the only way he can move is just like this. And if it's still a little confusing of which way he's moving, if I come over here to view, I can actually click and show the degrees of freedom for this guy. I should have had that turned on earlier. So see that little arrow that showed up after I clicked on degrees of freedom? That shows the only other way that he can move. There's actually 6 degrees of freedom in the XYZ directions and rotation in those directions as well. And you'll see those degrees of freedom disappear as you constrain your objects to one another. Okay, so he can still move around, and I really want to ground him over here. So I'm coming back to my Assemble tab. Now, the very last constraint you add, this may or may not work. We might have to get creative. Sometimes that last little bit to lock him into place, it will not like to go. So let's see if we can apply this. Oh, it did. It let us. If it doesn't let you apply surface to surface for that very last constraint, try just constraining a corner or an edge instead of the entire surface, and sometimes that'll let you do it a little bit better. Okay, so right now he has no degrees of freedom left. He can't move, and it's always good to kind of start your assembly with some sort of a big base that you're going to be attaching everything to that one base. And if you want to really be sure that he is going to stay where he is, I can right-click on him and say grounded. So now this is going to be the piece that does not move. Okay, once he's all in place, I'm going to go ahead and get rid of the visibility on all those planes. And now let's go ahead and bring in the next little piece. So place. There's my link number 1. And I'm going to come up here, place, link number 2. I have my degrees of freedom turned on, and you'll notice that these have 3 green arrows for XYZ movement, and they also they should have some little arrows showing the possibility for rotational motion as well. Okay, for these ones, you can actually do quite a lot with just this mate. You can do more than just surface to surface. You can also do axis to axis. So that's what I'm going to do here. I'm going to zoom in, and if you click on the curved surface, you'll get an axis for a hole. I'm going to go ahead and constrain that axis to this first link right here. Apply. Okay, so again, initially it's kind of might be hard to see how these two are constrained to one another, but if I change my orientation so that I'm looking right at the front of it, you can see that those holes are now lined up with one another. So it can slide along the axis, but we're now lined up with one another. So the last little bit that I'm going to do, and to rotate around, I'm pushing on my shift key at the same time I'm pushing on my roller button. Hopefully you figure that out. That's the same thing that CAD was. Okay, so constraint, and I'm coming in here. I'm going to grab this surface right here. See that red arrow? And I'm going to go ahead and constrain that surface right here to the back and say apply. Okay, so there is our first link, and we want to make sure he can still rotate. So if we zoom in on our degree of freedom indicator, you see this red circular arrow. That's what we want to see. So the only movement we can do is around. Now, if I come all the way around, you'll see he's bleeding through the frame. This is going to be some other joints that we're going to have to define in our dynamic simulation environment. But for now, at least we're constrained correctly. If we constrain correctly, this is going to, in the future, add some joints automatically for us that will make our dynamic simulation much, much easier. So we're going to add gravity to this thing and watch it move around just like it would move around in real life. Okay, so the last little constraint. Again, I'm coming in here and I'm clicking just anywhere on the inside of this curved surface, and that will grab that axis. And zooming in and doing the same thing for that last link, apply. And I need to constrain them one more time. So now the holes are lined up. But the last constraint is to turn them around, zoom in. I'm going to grab this surface and constrain it with this surface over here. Apply. Okay, so there's our 2 links. So that should make a nice little double pendulum for us. The next thing we're going to do is come under environments, and this time instead of a stress analysis, we are going to open up the dynamic simulation. So here we go. Do you want to start the tutorial? Some of these tutorials are halfway decent, so feel free to check out their tutorials if you want. I'm going to say no for now. So what we have, again, we're going to kind of go from left to right. Insert joints. The joints define how individual parts see one another. So they're not going to recognize that there's something there until you tell it. And you can open this guy up and go through all of the different joints. And they're pretty nice in that they have little animations that show you. Now, some of them can be a little bit tricky to set up. But let's look and see what it automatically created for us from the constraints that we already have. So you see the standard joints here, revolution, revolution. It's already connected our pieces to one another just based on the constraints we did. And this is the easiest way to create joints, is to just constrain it right to begin with. And it'll automatically populate that with appropriate joints to create the same motion. External loads. This is the only thing we need to do for this one, is to just add some gravity to it. While we are in construction mode, so this little gray guy over here has to be in construction mode, we're going to come over, right-click on gravity, and say define gravity. For gravity, we need a direction. So what I'm going to do is just grab a little edge over here, click on the edge, and then we can flip it up or down. So I'm going to make gravity down, and we can also define the value of gravity. We can come back later and redefine that if it's moving too fast or too slow. So I'm going to say OK. And I'm also looking at mobile group versus grounded group. So notice that the base over here on the left has a thumbtack in it, that it's grounded. And our mobile groups over here are the links. They can move, and that's what we want to have happen. They can move because of those degrees of freedom again. I'm going to go ahead and grab this guy and pull him up so that we get something interesting to look at here. And then I'll go ahead and let's play our simulation and see if this gravity thing worked. Woo, he's going kind of fast. Can go back to the beginning. If we want to go back into construction mode, I'm going to click on this guy right here, and let's just redefine our gravity to be a little bit smaller. I'm going to go ahead and make him, what do you think, order of magnitude smaller, 3.86 to 386. Okay, so that's a little bit smaller. And we can also define this to run for more than 1 second. So I'm just going to put 100 seconds in. We don't have to leave it run for that long, but okay, so now we have a slower motion and we can kind of watch it a little bit better. And it's flopping around. Now we haven't added constraints to keep it from going through the top of this thing yet. So it's bleeding through the top, but we have a nice little motion here. No friction, so this will just keep going and going and going forever and ever and ever. I'm going to go ahead and stop this and show you a couple other things here. One is the output grapher, and this is pretty neat stuff. We have the ability to graph tracers of any point along this. So we can keep track of any of our joints and what those joints are doing, any of our mobile groups. Let's go ahead and add a trace on this thing. So I'm going to click on the very end and see that little blue globby thing that I just stuck on the end. So we're going to trace the position of this. And before I exit out and say, okay, I'm going to be sure and check trajectory, velocity, acceleration. Let's just keep track of all of this stuff so that we can graph it all out. And the reference is our little piece that's grounded. Apply and okay. So now it actually just added in, this is the path that took through that last player. So if we open up our simulation player again, and go ahead and play it, you'll see that now it's keeping track of the position of this guy versus time. And if we open up our output grapher, we can actually graph this stuff. So this is great for physics experiments. We can look at energies. If you open up underneath the little assembly folder and open up underneath our tracers, this has position in the X direction, Y direction, Z direction. So anything that we checked that we wanted to keep track of with respect to time, here's acceleration. So that tells us about forces going on. And that's pretty nice to be able to see here. Okay, one other thing, you might notice this little Excel icon over here at our graph. Now, I don't want to export all of this out. What I'm going to do, let's see, Y is up. I'm going to export my Y position. So I'm going to uncheck a few things so I don't get too much crazy data. So I have position in the Y direction, and then instead of Vx, Vy, Vz, I'm only going to export the total velocity here. And I'm going to click on the little Excel button. Now that I've run my simulation, I've generated some data, and I've checked on what kind of data I want to export. And I have an option, single chart or to its own chart. I'm going to say each one to its own chart and then hit OK. And yeah, I'll just leave it at every one step. Now, if you come over here to Excel and open up Excel, you'll find the file that it created for us here. There's a couple different worksheets. So the first sheet has position in the Y direction. The second one has our overall velocity. It's got inches per second, so it has the units on here too. And then the third sheet has our data. So you can go ahead and save this file, and this is really nice if you're trying to figure out what kind of energies and forces are happening as these parts come together and move around. So very cool thing that you can export all of this neat kinematic and kinetic data into Excel. Okay, for the last little bit, let's have an initial look at the joints, and we'll do a little bit more of this after we put together some engine parts. Right now, the parts are bleeding through one another. They're constrained just on the joints, but they can't see one another, and you can see they'll kind of flop through one another. So what we want to do is change this so that they're not bleeding through one another. To start out, I'm going to go ahead and put my simulation player into construction mode. Remember, you have to click this little red thing before you can construct anything. Opening this up, let's go ahead and, oh, I already did it. Right-click on this and create a contact set. It's just right all the way down here at the base for your links. So go ahead and add the links into the contact set as well as your base. Go into a contact set. And let's come over here. So we're going to leave the Dynamic Simulation tab and come over to the Inspect tab and Analyze Interference. So this is where the trouble starts. Okay, so if I look at this top arm right now and my base, it says there's an interference detected. And if I zoom in on here, see that red area? So right now, if I added a joint right here, these guys would not be able to move because they're interfering with one another. So before putting a joint in, I'm going to have to actually redesign this base a little bit so that they don't overlap one another. Okay, so I'm going to go ahead and finish my simulation, come back to my base, and what we can do here is just slice this up a little bit farther. So which extrusion was that? We had our sweep command, And it looks like it was this extrusion, right? So I'm just going to double click on this extrusion. And instead of going up 0.5 inches, let's bump this up a little bit more, maybe 0.9. And that'll just let us have some more room for that to move around in there with. Okay, so I'm going to go ahead and save that new extrusion height. So there's that guy. Also, if I open up my sketch, that actually pulled up that little hole. So if I go ahead and slice graphics, I am going to put him, let's see, that was a 0.25 hole. So if I have him up, well, maybe he's okay. Yeah, I'm going to move him down a little bit. So here's my base point. And I'm just going to slide him down a little bit. So that should give our everything a lot of room to move around with. Okay, so finish sketch. So now that should give everybody a little bit more room to move around with. Save this guy, and let's come over to the assembly. And you can see our assembly is now updated with the edits that I did in my part. So it's kind of convenient. Keep all of your parts up and open along here in the base. So now we can come to inspect, analyze interference, and again we're going to look at this top arm and the base, and yay, there's no interference detected. So now that he can move around a little bit more, let's go back to the dynamic simulation and insert some joints. So here's the 3D contact joint. For this one, component 1, I'm going to grab the arm. And for component 2, I'm still going to be a little bit careful with this. These joints, they'll get stuck pretty easily. So for component number 2, I'm actually just going to grab this ceiling right up here on the top of our extrusion. So there we have it. And if we open up our menu over here, you can see where that 3D contact was created. So cross your fingers, let's start the simulation player and see what happens here. So I'm going to go ahead and play this, and it's not moving, so it doesn't like it. And this is the fight that you'll have over and over again with creating these joints, because it's pretty hard to get two things to actually move without fighting one another. And we can have a long conversation at this point at tolerances, but this video is already too long. So what I'm going to do is I'm going to put in a simpler contact. So I'm going to come over here, put myself into construction mode, delete that 3D contact we made. So now we're back to where it's moving around. And I'll do a 3D contact, but this time I'm not going to do it. I'm going to just tell this ball that I don't want this ball to go through the base. Okay, so that's probably a little bit safer of a constraint to add. So here we go. Let's just wait for it and see what happens when that ball comes back up to the top again. And hopefully he will bounce away from the top instead of bleeding through it this time around. Okay, so just wait. I think this is the one where he was going to come. And boom, did you just see him bounce off the top right there? Let me zoom in a little bit. And here's the replay of that bounce. So now you can see that at least these two objects now see one another. Okay, for the last little bit here, what you're going to do is save that assembly, and let's open up a presentation. Check out what those things are about. First thing you have to do, insert your model. I'm going to just grab that assembly we created and pull it in here. And what we have is our storyboard, and assemblies are created in order to show each little individual part of it. And so what the point of it, I'm going to click on Tweak Components, and we're going to explode our object. Now we're not actually taking apart our assembly. This is purely for showcase purposes. So you're showing people what parts are in here. Okay, so I'm going to select some parts, and maybe I'll move both of these together. So if you hit Shift, you can select more than one piece, and then right here, these arrows, you can select which way to drag. So I'm going to drag these away, and let's make these 2 inches. You can also decide how long this movement is going to come. We're actually making a video here, and you can look at trails or no trails, so these little lines showing what direction the parts were moving in. So all parts are just a single trail for everything together. And we can go back and change these later on. So I'll say plus, and then I'll tweak the component again, and let's just move this one this time around. So there's another 2 inches maybe. I'm also going to use a couple of capture cameras. So maybe we want one view to be here, but then we also want to kind of revolve it around to the other side over here. And maybe we want to kind of really zoom in on this thing. Okay, so I'm going to say capture camera for this zoom too. After we have a couple of these, I'm just going to pull up my storyboard here. And everything we've created is on the storyboard. So if I want to click and drag something, I can change the duration of the time that it takes. Okay, so you can go ahead and play the videos you've made and see how it walks through the different camera angles and the different animations. Do that in the forward mode and the backwards mode. Let's see, another couple things in here. Tools, under Tools and Style Editor, we've got various different lighting and backdrops. If you just right-click, you can make some of these different things the current background style. So try some of these guys out. Some of those might be a little bit too big. You actually get like one of these 3D camera views for some of these, so it's a little bit more than just a picture. And you can come up here and mess around with your lighting. So here's your shadow effects. You can put some shadows on there. See those little shadows showing up. You can put reflections on here, make everything a little bit shinier. Okay, at the very end, under Presentation, once you're happy with how your video looks, and it can take a little bit of time before you like it, go ahead and click on Video, and you can create just a WMV file or a AVI file. Make it a WMV. Okay, so just go ahead and save it somewhere. And for this assignment, what I want you to do is create a movie, create an assembly, and then all of your parts should all go in that double pendulum Dropbox folder. Okay, so have fun with it. I look forward to seeing your designs.